Okay, hi everyone. We're graphing sine graphs today, and our pattern for sine graphs are a sine of bx parentheses negative c plus d. There's actually a couple different ways people rephrase it. Sometimes people use a plus c. I always write it as a minus c. Sine of bx. Okay, and we are not going to work with c yet. This is our phase shift, and that means we're moving the graph left and right. We have our d, which is our vertical shift. Oops. And that moves the graph up and down. And then our b is our period. Well, b is not our period, it's really our frequency. But we use it to determine our period. P is equal to 2 pi over b, period. And we have our a value, which is our amplitude. So each of these characteristics, it's almost like ordering your Tesla. You want a red Tesla, you want a black Tesla, you want a white Tesla. Which rims do you want? Which battery capacity do you want? Do you want the one with ludicrous mode? Okay. Which Tesla do you want? And that's what we're doing here. And depending on which Tesla you want, a Model 3, a Model Y, a X, or S, you get a different car. You get a different graph with all these features. Oops, thank you. If I'm not scrolled all the way up, I can't see people trying to get in. Okay, so these are the features that we're going to deal with, A, B, C, and D. And we're going to talk about all of them today. So let's start with y is equal to 3 sine of x plus 1. Okay. So we want to label our A, B, C, and D value. So for every graph, we're going to practice setting up A is equal to 3, B is equal to, B is always the number next to the X. So that's going to be a 1 for us because it's invisible 1. We don't have a parentheses, so no C, and D is equal to 1. D is always a number by itself. So make sure you take these notes, and these are our characteristics for our sine graph. Now, as we talk about this, we said that we want to start from right to left. Just like Subway, we got to figure out where to start, and we're going to start graphing D first. Now, why D and not A? A seems like one of the easiest values we can graph. We talked about it before. A is your amplitude, how high or how low the graph is. If it's a half, if it's like a 3, if it's a 5, why don't we graph A? It's because what if I took your graph, instead of being here, it was up here? And that's what our D value does. It moves our graph up. So let's start off with D. So we draw a cross. That's what we do, draw some arrows. That's the first thing we do. And then we label our D. Our D is 1. Oh, sorry. Well, we're going to rewrite it again, okay? We'll rewrite it again. But A is our amplitude, B is our frequency, C is our phase shift, and D is our vertical shift. And we also wrote this in our previous notes. I'll just squeeze it over here so you have time. So we graph our D first, and D is 1. That's a vertical shift, right? It said it's vertical. So D is 1. So at Y is equal to 1. Draw a new horizontal line because everyone got bumped up. We're moving on up. D is now 1. Okay, it's almost like you got in a car elevator and the elevator moved your car up. Have you seen those before? The car garages that move your car. Your car doesn't move. And then our C value is 0. That means we start at 0. It means our graph is going to start here. Our B value is 1. So P equals to 2 pi over 1, which is 2 pi. Here's 2 pi. Mark. We do half, half, and half. We said we wanted to make our graphs look really well balanced. So we have to cut this in half, half, and half. Why do we do that? Because I don't want your waves super strong and little tiny at the end. See, the halfway mark should be there, not way over here. I don't want these graphs looking terrible. I want them to look nice and well modeled. Okay, so half, half, and half, 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 and half. And then we copy all our tick marks to our D value. Remember, this is one floor up. So everyone hops on this elevator and goes up. So we did D, we did C, we did B. B is how long it takes me to finish one graph. And only thing we have left is A, which is our amplitude. So from our D value, remember we're moved up by 1. We take 1, 2, 3 steps going up, and 1, 2, 3 steps going down. And our graph is going to happen in between these lines. And we joked about bumper bowling. If you guys have ever been bumper bowling, they put up these gutter blockers so your ball never falls into the gutter, and kids just make these crazy Z patterns across. Bumper bowling, literal thing. Okay, so we're going to describe how do we graph this now. Now, looking at a sine graph is, we're always referring to a unit circle here for when it comes to sine and cosine. Let me draw the unit circle for you guys. Here is our unit circle with 4 special points. This is 1, 0, 0, 1, -1, 0, and 0, -1. Now, why did I bring up the unit circle? Well, if you remember, sine and cosine were part of that unit circle. And we mentioned before that the sine value is our y value, and our cosine value is our x value. So at 0 degrees, at pi over 2, at pi, and 3 pi over 2, these actually relate to all the markings that we just drew. 2 pi, half of 2 pi is pi over 2. This is pi over 4. Oh, whoops, sorry, my bad. Half of 2 pi is pi. I don't know why I did that. So this is pi now. This is pi over 2. And this is 3 pi over 2. Those are our 4 tick marks. So what is sine at 0? Sine is your y value. Sine is 0, but 1 step up. So the idea is that if I know this is a sine graph, it's always going to start at the middle of the graph. Our next value is going to be 1. So 1 times 3 is 3 plus 1 is going to be 4. Turns out we go all the way up. 0 up, sine of pi is 0. Sine of 3 pi over 2 is -1, all the way down to the bottom of our bumper, and back to 0, all the way to our middle. Now, let's talk about this again. If I gave you a regular sine graph, y is equal to sine of x, a is equal to 1, b is equal to 1, c and d are both 0 here, we would start off with a graph. D is 0, c is 0, our b value is 1, so our period, we need to figure out how long it takes me to finish this job. It takes me 2 pi to finish. Mark it off at 2 pi. Half, half, and half. Half is pi. Oops. This is pi over 2. And 3 pi over 2. Count up by 1, 2, 3. And then our a value is up 1, down 1. For this graph here, we follow the same pattern. Sine starts off on 0, 1, 0, -1, 0. Sine starts off like you wake up in the morning. You start off right in the neutral position. Then you get up, then you come back down, all the way down, and then back up. And that is a basic sine graph. Now, how does our basic sine graph compare to the graph that we drew before? Okay, so the amplitude here is 3. So the graph would be 3 times as large. Amplitude is the volume. If you're into sound music at all, when you turn up the volume, you don't change your beats, you don't change the octave, you just change how loud that wave is. That's amplitude. So this was 1, 2, 3 up, and 1, 2, 3 down. So it's a larger graph going up and down. What did the D do to my graph? Remember the D value here? That shifted the graph. Instead of at 0, it moved everything up by 1. So the graph is now, look, it's one space higher than it should have been. Oops, it should have been. Darn it. Should have been. What did the, well, everything else was the same. B was 1, the period was 2 pi. We stopped at 2 pi for both graphs. Now, all sine functions, when we first start, will always follow this path. 0, up, 0, down, 0. It's what we call a sinusoidal graph. Sinusoidal. And that just refers to this graph that keeps going up and down in waves. The waves go up and down, up and down, up and down. And whenever you hear the word wave in physics or in math, the wave graph is a sine graph. It just keeps rolling in and rolling out, rolling in and rolling out, rolling in and rolling out. Now let's look at this again. Let's do another sine graph. And let's take this graph and we're going to add some characteristics to it again. It's like buying ice cream at Baskin Robbins and all of a sudden kicking it up a notch. Add some peanuts, add some chocolate fudge, add another scoop maybe, make a bigger scoop. So that's what we're going to do. So let's give ourselves some values. Y is equal to 2 sine, let's not do 2, let's make it weird. Let's make it 1/2. Let's shrink it. 1/2. I'm going to quiet that volume. Sine of 2x minus 1. Now, we mentioned before that the b value is frequency. And how is that related to a period? It's 2 pi over b. Now, why is that true? Why is frequency and period kind of similar? And the example, again, as I mentioned before, is when you take medication. When you guys ever go to a pharmacist, the pharmacist will tell you, take this medication twice a day. Twice a day is a frequency. It's a number of times. So the number of times I see this graph is going to be twice every 2 pi. Well, thank you. Twice a day, twice every 24 hours. Great. But if you try telling this to your grandma or a kid, 2 times a day means I can eat 2 of them at the same time. That's twice a day. But that's not what he means. He means he wants to space them out. If I take 2 pills every 24 hours, isn't that really 12 hours per pill? And what happens is we take our time and we divide it by our frequency. Oops, 24 divided by 2 is 12. And this is our period. Whenever you divide the frequency by the period, the length of time, the total length of time, that's what our period is. So let's look back here. If my frequency here is 2, that means in 2 pi, that means it takes me 2 pi over 2 pi to finish one period. One graph should take me pi to finish. What happens if I half your allowance? Is your graph like super big or super tiny? It should be super tiny. And that's what that 1/2 is going to affect our amplitude. It muffles our volume. Anyone ever play a piano and you're playing with the pedals? One pedal sustains the song and one pedal dampens the sound. Right? So that's what this does. It dampens. So let's go ahead and write this out. We have A equals to 1/2. B is equal to 2, which gave us the period of pi. That looks terrible. Let me rewrite that. 2 pi over 2, which is just pi, and that's our period. Our C value is 0 because no parentheses, no C. And our D value is -1. When we graph these, we always go from right to left. And right to left. So we're going to say it's 2 pi here. But, oops, sorry. That's not how we're doing. Let's do D first. D first is -1. And I make the dots here. Now the frequency said we're going to see the graph happen twice in 2 pi. Well, fine, you can just squeeze 2 in there. Oh, darn it, that's not 2, that's barely 1.5. Let me try again. Oh, that's not 2 either. Maybe, nope, that's too short now. Gosh, this is so difficult. I'm being sarcastic, of course. So what I do is I ask you guys to tell me the period. Don't tell me how many times, tell me how long it takes me to finish. Imagine if I told you you have 10 homeworks today. You're like, oh man, Mr. Cole, that's crazy. If I told you each length of homework is only a minute, like, that's not bad then. So period is more understanding for us as humans. So it takes me pi to finish. So where does pi fit into pi? Well, here's pi, right? And then from here, we go half, half, and half. Copy the tick marks over. If you want, you can rewrite the tick marks pi over 4. No, pi over 2, sorry. Pi over 4. And 1, 2, 3/4. 3 pi over 4. Those are the tick marks in between. Okay, let's double check. We got D as -1 because we're one step down. We got C, we're starting at 0. Great. We have B, we said how long it's going to finish one graph. This is one graph right here. It's going to be finished and done in one graph. Now, our last letter is amplitude, and the amplitude is 1/2. So what is 1/2 above and 1/2 below -1? And it looks like this tiny sliver of a graph now. Now, if you look at my dotted lines, hopefully they'll look confusing now, but they'll be helpful later. Because remember, you're stuck between these two lines. You have to graph something in between here only. You can't jump out. The 1/2 helps us remind us that we are stuck between those lines. Okay, sine always starts at 0. That's the hint. When you sin, you lose. We're at 0. And the pattern of a positive sine graph is go 0, up to my amplitude, down, down to my amplitude, and back to 0. So if you look at my graph, this graph is a whole lot thinner. If we continue this, well, it took us pi to finish one graph, right? So 2 pi to help us finish the second. Let's do it again. We're going to draw our tick marks, half, half, and half. So we can squeeze 2 graphs here, half, half, and half. So we follow the pattern, 0, up, 0, down, 0. So we were able to finish 2 graphs. We finished 1, 2, 1, and 2. And that's where the b value comes in. That's what b means. I see this graph twice in 2 pi. How long does it finish one graph? It takes me pi to finish one graph. If I have 2 graphs in 2 pi. And that's what the frequency refers to. I see this graph twice in 2 pi. Okay. Now, I'm going to graph this same exact graph now, except I'm going to use the word cosine. And how does cosine change? So a cosine graph looks just like a sine graph, except it just starts at a different point. Now, let me show you the unit circle again. This is 0, 1, 0, -1. So it's 1, 0, 0, 1, -1, 0, and 0, -1. If you start off looking at the y's, please look at the y's. This is our sine value. 0, 1, 0, -1, 0. Graphing it on a line. 0, 1, 0, -1, 0. 0, 1, 0, -1, 0. Is everyone kind of okay with that? Sine at 0 is 0. Then our next move would be all the way up to +1, coming back down to 0, and then -1, and then back to 0. Okay, that's a sine graph for us. Whenever you see sine, this is what you're going to see. But what about cosine? cosine we said was x, right? So please look at cosine. This is cosine here. Cosine is x, cosine is x, cosine is x. What is the value of cosine at 0 degrees? Is it 0? It's 1, isn't it? So that's actually where we start. We start at our amplitude 1. We're up here. Again, cosine is in red. That's cosine of 0, and that equals to 1. Taking a look here, cosine of 0 is 1. We move from here. Next point is, what's the cosine at pi over 2? It's going to be 0. We're down over here now. What's the cosine of pi? That's -1. We're way down here. It's almost like cosine is mimicking sine, except it's one step behind. See, it's one step behind. Let's come back up. From -1, we go back to 0, and then all the way up to +1. A cosine graph looks like a parabola, but it's not a parabola. Please, it is not a parabola. It's not. A parabola shoots off, whoosh, shoots off. A cosine graph is going to come right back down and continue the cycle over and over and over again. Now it looks like a DNA, double helix. Okay, so they are related. Sine and cosine do follow the similar patterns because they're really just repeating a circle over and over again. But one just starts a little earlier than the other. So here's the hint. Cosine always starts at your amplitude because it always starts at 1, while sine starts you as dead in the water. Sine starts you off at 0. So let's go ahead and graph what we graphed before. 1/2, y is equal to 1/2 sine, nope, not sine, I'm sorry. We're going to do cosine now. Cosine of 2x minus 1. So I'm going to graph this graph above here, just so that they're next to each other. You can graph them anywhere you want. I just want you guys to be able to see them both at once. Let's talk about our A, B, C, and D. Let's see if you guys can guess what my A is. A is in front. What do you think my B is? B is always next to X, which leads me to my period, 2 pi over 2, which is pi, right? That's the period. If I want to see 2 of these in 2 pi, it's going to take me pi to finish each. My C is 0 and my D is -1. So again, you can graph this anywhere you want. I'm going to graph it right here. And let's start off with D, A. Remember, we always graph starting from D, because don't start graphing if you don't know what floor you're going to be on. Okay? Don't start buying furniture before you figure out where you're moving. Don't buy furniture if you don't know if you have a 2-bedroom or 3-bedroom house. Oh, but I'm moving. Yeah, but you don't know how big the place is. So we don't start drawing anything until we figure out where we're gonna, what level we live on. We live on -1. Here's our -1. Our C value is 0. That means we're going to start at 0 like everyone else. Our period is pi. That means we're going to stop at pi. Half, half, and half. We always, after you draw your period, draw half, half, and half, because we want to make sure we spread out our graph. If you don't do the half, half, and halves on your test, if it's not labeled nicely, I'm going to have to minus points. Half, half, and half. Copying this onto my graph. Remember, this is the x-axis, you could say, or my theta, and we're just copying it down to my d value now, so we know where the center is. A value is 1/2, so we're going to do 1/2 above our d value, 1/2 below our d value. Now, this is 99%, just like what we did before. We graphed our D, C, B, A, all our values, the same exact order. What's the difference? Remember, it's all about where you start. Sine starts at 0, cosine starts at 1. So us starting at cosine means we are starting right on top. Cosine is up, 0, down, 0, up. We form this kind of wave thing going on. And the graph keeps on going in both directions, coming back down. Now again, if you look at the difference between sine and cosine, they look really different, but they're not. They both have the same A, B, C, and D value. Okay, that's how we set up the graph. That's the framework of it. That's our structure. But sine starts at 0. It will always start at 0, and cosine will always start at 1, the amplitude. Now let's go ahead and graph another one of these as we practice. Y is equal to 2 cosine of, let's do something weird. Let's do 3x plus 1. Please label your A, B, C, D. Remember, these are our characteristics, just like slope and the y-intercept. Just copying those letters. Make sure you don't mess up on negative signs. And our B value is really 2 pi over B, which tells us the graph is 2 pi over 3. That looks terrible, but it's okay. Mr. Ko says it'll be okay. I draw my cross. I'm gonna try to squeeze this someplace. We graph D to A, okay? Because I don't know what's my amplitude if I don't know where the center of the graph is. D is 1. Here's D is 1. That's the center of my graph. C is 0. That means we're going to start at 0. We're not going to shift forward or back yet. We'll learn about that later. Now, how long is my period? Now, please, don't freak out about period. Just make a mark, 2 pi over 3. This is my graph. I control where I write 2 pi over 3. Half, half, and half. Now, what is half of 2 pi over 3? If you don't know this trick yet, we multiply the bottom by 2. Let's say you have the number 10. What's half of 10? Don't you just multiply the bottom by 2? That's 5. What is half of 100? You just multiply the bottom by 2. What is half of a half? Just multiply the bottom by 2. And a quarter is half of $1. So what's half of 2 pi over 3? Half of it is 2 pi, multiply the bottom by 2, is 2 pi over 6. That reduces to pi over 3. That is half of 2 pi over 3. What's half of pi over 3? What's half of 60 degrees? Half of 60 degrees is 30 degrees, pi over 6. Counting. 1 tick mark, 2 tick marks, 3 tick marks. This is 3 pi over 6, which is reduced to pi over 2. So practice that, work on it. It's not too hard, you just gotta get used to it. Now that we have our setup, we have D, B, the DC, B, we just need A now. A is 2. So from the center, we're gonna go up 2 and go down 2. Is this a sine or cosine graph? Because remember, sine starts in the middle, cosine starts at 1. Since this is a cosine graph, we're going to start off at positive 1, I mean up here. So cosine always starts at the tips. And then we do our tick marks. Up, coming down from the roller coaster, down, all the way down, back to the middle, and back up. I am not using the x-axis. I'm using my D value as my new center. Up, 0, down, 0. And then we come back again as this process repeats.